Okay, alright friends, good morning. So today we will be continuing with number system. Today we will be completing the number system. So in today's session we will be doing three important topics, that is divisibility rule, remainder theorem and also LCM and HCF. Okay. So in the last class what did we study? Unit digit and also number of digits, correct na? Unit digit and also number of digits, those are also very important topic. Like I told, in number system we are having 7 topics. From these 7 topics you will get at least 3 questions in your CSIR NET exam and also at least 2 questions in your SET exams. Okay. So let us start with divisibility rule. First, anyone tell me in the YouTube, am I audible? Just check once. Am I audible? Check in the YouTube once. Good morning, Sri Agna Mudiraj. Good morning. Let me only check. Okay. Yes. Alright, so let us start with divisibility rule. Okay, some of you have already attended the number system classes, but there are many new students and also for you it will be a revision. Okay, these 60 days will be revising all the topics, be it general aptitude and also be it for what? Logical reasoning, and also will be covering the syllabus that is there for your SET paper 1. Like I told, I will be covering 5 to 6 units of your SET paper 1. Okay, I told you in the first class itself. Those who have missed the first class, please watch the first class, that is on the YouTube itself. Okay. When it comes to divisibility rule, okay, you have to learn the divisibility rule for 2, okay, then 3, along with 3 let us learn 9, okay, then you have to learn 4, along with 4 let us learn 8, okay, then what is this left? 6, correct na? 6 is left, then 7 is left. Okay, when it comes to remaining, what is there? 5 and 10, 5 is there and 10 is there. We have to learn divisibility rule for 11, very important, 12. So let us learn till 12. Okay, when I talk about 2, okay, when I talk about 2, let us take separately each of them now. Okay, when I talk about 2, the number, to know whether it is divisible by 2 or not, the very simple thing is it should be an even number. Okay, that the unit digit should be an even number. Okay, the unit digit should be an even number. If the unit digit is even number, the entire number is even number itself. Suppose I give a number like 1, 2, 3, 6, 8, 1. So definitely this is not divisible by 2 because it is not an even number. Okay, if I make this 2 or 4 or 0, this will become an even number, so it is divisible by 2. Correct na? So any number which is ending with an even number, then it will become a number that will be divisible by 2. Very simple. Now when it comes to divisibility rule by 3, okay, so whatever the number they have given, if you add it, okay, if that number is divisible by 3, then definitely the whole number is divisible by 3. Suppose if I give example 111, okay, here the trick is what? Sum of the digits must be divisible by 3. Sum of the digits must be divisible by 3. Must be divisible by 3. Here sum of the digits is what? 1 plus 1 plus 1, it is 3. Correct na? It is 3. So 3 is divisible by 3. So definitely 111 is also divisible by 3. Correct na? 111 is also divisible by 3. One more example. If I take 1 to 1, 1 to 1, sum of the digits is what here? 4. 4 definitely it is not divisible by 3. So sum is 4. So this is not divisible by 3. So definitely 1 to 1 is also not divisible by 3. Now if I take 132, 132 sum of the digits is what? 6. So 6 is divisible by 3. So 132 is also divisible by 3. Okay. Suppose we take, yeah. So I was telling, when it comes to divisible by 3, sum of the digits should be divisible by 3. If it is divisible by 3, the number that is given will be divisible by 3. Suppose I give 144. 144, what is the sum here? 9. So 9 is divisible by 3. So definitely 144 will also be divisible by 3. Suppose I give some random number like 289267. So please Find the sum of this. 34, correct na? 34. 34, you add once more 34. 3 plus 4 is what? 7. 7 is not divisible by 3. So definitely this entire number is not divisible by 3. Correct na? This entire digit is not divisible by 3. So if I make this, instead of 7, if I make this 5, or if I make this 4, if I make this 4, what is the sum now? 30? What is the sum now? 31. See, add this, 8 plus 2, 9, 19, 21, 27, 31. So again it is not divisible by 3. If I make this 3, so 30 is divisible by 3, so this entire number is divisible by 3. Okay, same thing goes for 9. 9 also, why I have written together is, so 2 it is even number, 3 sum of the digits should be divisible by 3. When it comes to 9, sum of the digits should be divisible by 9. Same like 3, here it is, it should be divisible by 9. So when I talk about 9, okay, when I talk about 9, the sum of the digits should be divisible by 9. Good morning, Shilpa. Okay. We talk about 9. Here also, sum of digits should be divisible by 9. Should be divisible by 9. Okay, so let us take a number. 144. What is the sum here? 9. So definitely 9 is divisible by 9. Definitely 144 is divisible by 9. Actually 16 9s is 144. Okay, so 144 is also divisible by 9. So if I tell 729, what is the sum here? 18. 18 is divisible by 9. Definitely 729 is also divisible by 9. Okay, let us take one more number. What is the sum here? 18. What is the sum? Yeah, 18 only. I will ask simply 18 only. So 18 is divisible by 9. So definitely 1278 is also divisible by 9. 18 is divisible by 9. So this is also divisible by 9. Okay, 1278 is also divisible by 9. I hope it is clear now. Okay, 3 and 9 follows the same rule, but 3 should be divisible by 3. This one 9, sum of the digits should be divisible by 9. Clear? Understood? 3 and 9. So 2 should be even number, 3 should be sum of the digits should be divisible by 3. Okay, 9, sum of the digits should be divisible by 9. Okay, next let us go to 4 and 8. When we talk about 4 and 8, so 4, see 4, last two digits should be, I told about this while talking about cyclicity of 4, while talking about unit digits. Last two digits should be divisible by 4. Last two digits should be divisible by 4. Okay, suppose I give a number like this, 312. Is it divisible by 4 or what? You have to focus only on last two digits. Last two digits is what? 12. So 12 is divisible by 4. 4 3s are 12. So definitely 312 is also divisible by 4. Okay, so if I give another number like 722. 722. You have to focus on only last two digits. Focus only on last two digits. So what is happening? 22 is divisible by 4? No. 4 5s are 20. You are getting a reminder. So 22 is not divisible by 4. So definitely 722 is also not divisible by 4. Okay, let us take one more example. See, first of all, understand one thing. If it has to be divisible by 4, one of the thing is it should be an even number also. Correct, na? First of all, if it is not even number, it will no need to check also. Okay. First thing is, if it has to be divisible by 4, any number that is divisible by 4, okay, it will also be divisible by 2 also, because 4 is what? 2 into 2. So first thing is check whether it is even or not. Then check for last two digits. Okay. First thing is it should be an even number. First of all, this is not an even number, so don't even check. Not required. Okay. If I say 173, this one also no need to check, because this is not an even number at all. No need to check. If I say 174, this is an even number. Okay, so we have to check. But whether it is divisible by 4, no. Because 74, if I take it, see 4 1s are 4, 34 is there, 4 8s are 32, 2 remainder is coming. So 74 is not divisible by 4. So 174 is not divisible by 4. 174 is not divisible by 4. Okay, just because it is even doesn't mean that it is divisible by 4. So come out of that misconception. If it is even, if it is divisible by 2, but not 4. But for a number to be divisible by 4, first of all it should be an even number. If it is not an even number, don't even check. Just because it is even number doesn't mean that it is divisible by 4. It is definitely divisible by 2, but not by 4. You have to check last 2 digits. What you have to do? You have to check the last 2 digits. Okay. Now don't get confused. Check the last 2 digits. If it is divisible by 4 means that's it. Remaining entire thing is divisible by 4. Suppose I give an example, another example. Let us take one more example. See here. Is it divisible by 4, this entire number? Why? Because this 96 is divisible by 4, so this entire number is divisible by 4. Now, I hope it is clear for you when it comes to 4. Now, let us look for 8. When I talk about 8, okay, when I talk about 8, what will happen is, if you see here, when I talk about 8, last 2 digits what we are talking for? 4. When it comes to 8, it becomes last 3 digits. Okay, it will become what? Last 3 digits you have to check. Last 3 digits we have to check. Okay, first example what I gave for 4 is 312. So let us take 312 only. Okay, or let me take 5312. Okay, now to check whether it is divisible by 8, we have to check last 3 digits. Here also it should be an even number. See, 2 is a multiple of what? 4. Okay, 4 is a multiple of 8. So whenever you talk about 2, whenever you talk about 8, whenever you talk about 4, whenever you talk about 16, definitely they all should be divisible by what? Not divisible, they should be even number. First thing, they should be even number. So first of all, is it even number? Yes. So let us check. Now suppose I had given 5311. If I ask whether it is divisible by 8, definitely it is not divisible by 8. No need to check at all, because it is odd number. Okay, it is odd. Okay, it is odd number, so we cannot, no need to further check. Now this one you check. So you have to check for divisibility by 8 means, see whether the last 3 digits are divisible by 8. So what I should do? I should divide by 8. So this is what? 8, 3s are 24. Now what is left? 7. 72 is there. 8 9s are 72. So definitely divisible by 4. So definitely 5312 is also divisible by 8. Not 4, 8. Okay, clear? So when you talk about 4, you have to check for last 2 digits. When you talk about 8, check for last 3 digits. That's it. Very simple. 2, it should be an even number. 3, sum of the digits should be divisible by 3. 9, sum of the digits should be divisible by 9. 4, last 2 digits. 8, last 3 digits. Check for last 3 digits. So let us take one more example. Check for this. Whether it is divisible by 8 or not. Check. What I have to do? I have to check for last 3 digits. It is not divisible, because see, 8 1s are 8. What is left? 18. 8 2s are 16. Okay, 22 is left. Correct na? 22 is left means 8 2s are 16. Remainder is coming. So it is not divisible by 8. Clear? Understood? So till now we have studied 2, 3, 4, 8, 9. Correct na? Now when I talk about 5 and 10, very simple. Whenever I talk about 5 and 10, it should end with 5 or 0. Whenever I am talking only about 5, see, when I talk about 5, please be careful, don't get confused. 5 means end with 5 or 0. Okay, end with 5 or 0. Okay, any number ending with 5 or 0 is divisible by 5. Any number ending with 5 or 0 is divisible by 5. 10 end with 0, not 5, end with 0 only. Okay, 5 means it is both 5 and 0, 5 or 0. Okay, when it comes to 10, end with 0. Any number, if it is given, if it is ending with 5, it is divisible by 5. If it is ending with 0, it is divisible by 5. If it is ending with 0, it is divisible by 10. Okay, this is about 5 and 10. Now when I talk about 7, there is a trick for 7, but I don't want you to follow it, because that trick itself will take more time. Instead of that, what you can do, whatever the number they have given, divide by 7. Suppose I say 2835 is given. Okay, I can tell you the trick, but that is not required. If they ask you to find whether it is divisible by 7, what you can do here? 7 4s are 28, 3 I will take, another 5 I want to take, I will put 0. Okay, 7 5s are 35. So it is divisible by 7. Directly you can find out for 7. Suppose they have given 2837. 2837. 7 4s are 28. Okay, 7 4s are 28. Okay, again you will put 0. This is what? 7 5s are 35. Remainder is what? 2 is coming. So it is not divisible by 7. That's all. When it comes to 7, directly divide. When it comes to 7, directly divide. There is no trick you have to follow. Okay, don't follow any trick. Okay, for 7, directly divide and see it. Now what is left? 10 is done. Now we have to look for 6. Correct na? When I talk about 6, you should be careful. See here. Now we are checking for 6. So first of all, 6 itself is multiple of 2 and 3. 6 can be written in terms of prime numbers as what? 2 and 3. Correct na? So whenever I write 2, you should understand that it should be an even number. Any number, first thing for it to be divisible by 6, first thing it should be an even number. Okay, if it is not even, don't check for 3. So for 6, for checking for 6, first thing the number should be an even number. Okay, first condition. After that you have to check whether it is divisible by 3. To check for divisibility 3, what you should do? Sum of the digits should be divisible by 3. That's it. Okay, suppose I give a number 1296. Okay, whether it is divisible by 6, first condition, yes, it is an even number. So there are chances it is divisible by 6. Next I have to check for 3. To check for 3, what I should do? I should add it. 6 plus 9 is 15, 15 plus 2 17, 17 plus 1 is 18. 18 is divisible by 3. So it is first even, then it is divisible by 3. So definitely this is divisible by 6. Understood? Definitely this is divisible by 6. Suppose I give a number like this, 1277. If I ask you to find whether it is divisible by 6, definitely it is not, because first of all it is not an even number. Okay, it is not an even number, so don't check. So definitely it is not divisible by 6. Suppose I give something like this, 1282. 1282 is given. Now check here, first of all it is even number, so there is possibility. Now check for 3. Divisibility by 3, what you should do? You should add it. 8 plus 2 is 10, 10 plus 2 is 12, 12 plus 1 is 13. 13 is not divisible by 3. 13 is not divisible by 3. So that means what? This entire thing is not divisible by 6. This entire thing is not divisible by 6. Understood? First thing, it should be an even number. Okay, next thing, it should be divisible by 3. Okay, it should be divisible by 3. Then definitely if it is following both of these, not either of these, I am telling both. First it should be divisible by 2. Divisible by 2 means what? It should be an even number. Then it should be divisible by 3. Okay, then definitely it is divisible by 6. Okay, so first you check whether it is an even number or not. If it is even number, then only check for 3. Okay, you came late, don't worry, you will understand. Watch from the beginning once again, you will understand. So this is about 6. Now what is left? If I talk about 12, if I talk about 12, understand one thing, 12 can be written as what? 12 can be written as 4 into 3, or it can also be written as 6 into 2. Okay, so whenever you want to check for 12, either you can check it like this 6 into 2, or you can check it like 4 into 3. Let us go with 4 into 3, easy for us. Why? See, any number that is given, if you have to check for 4 into 3, so see here, suppose they have given 1278, this is the number that is given. So first of all, this number that is given is even. Okay, so let us check for last 2 digits. Last 2 digits is divisible by 4. To check for 4, what we should check? Check last 2 digits. Okay, last 2 digits is what? 78. 4 1s are. Okay, 38 is left. 4 9s are 36. 2 is remainder. So it is not divisible by 4. No need to check further. So this is not divisible by 12. Okay, 4 and 3 you check. First you check for 4. If it is not divisible by 4, no need to check for 3. Okay, no need to check for 3. Okay, check for 3 at the end. Okay, earlier only you are getting it that it is not divisible by 4, no need to further check for 3. Okay, both it should be divisible. It should be divisible by 4 also, it should be divisible by 3 also. Then only you can consider, because 4 into 3 is 12. Correct na? So first you check for 4. If it is not divisible by 4, no need to check further. Okay, so this is it when it comes to 12. Suppose they give 24. Suppose they give divisibility by 24. What we should do? So they give 24. So what we can do? You can write it as 6 into 4, or you can write it as 12 into 2, that is also fine, or 8 into 3. Okay, 8 into 3 is better. Okay, whatever way you do, it is fine, no problem. So 8 into 3 means the given number, first you should check for 8. What to check for 8? Last 3 digits should be divisible by 8. Correct na? Last 3 digits should be divisible by 8. Then what you will do? If it is divisible by 8, you will check for 3. Suppose I had given an example 5312. Okay, this 312 is divisible by 8. See, 8 3s are 8 9s are 72. Correct na? So 312 is divisible by 8. Now this is tick, not a problem. Now let us check for 3. So 5 plus 3 8, 8 plus 1 9, 9 plus 2 11. So this 11 is not divisible by 3. So this entire thing is not divisible by 24. Understood? Understood? Clear? So this is it when it comes to 12. This is it when it comes to 24. Like this you can do even for other numbers. Even for other numbers, see, suppose they have given. So we learned 12 and 24. Suppose they give 16. What you can do? You can write it as 8 into 2. If they give 18, you can check for 9 into 2. For 18, what you will do? First, whether you will check whether it is an even number. So that it is divisible by 2. Then you will check for 9. For 9 means what? Sum of the digits should be divisible by 9. That's it. Next thing, if they ask 36, 36 can be written as what? 36 can be written as 18 into 2 or 9 into 4 or 12 into 3 also. But write down in the form of least numbers. So 9 into 4 is given. Correct na? So first you will check what for 36, whether it is divisible by 4 or not. Okay, then you will check for 9. Okay, so for 36, suppose I write 108. If I write 108, first I should check for 4. Last two digits is what? 08. So 8 is divisible by 4. So it is satisfying this condition. If I have to check for 9, sum of the digits is what? 9. 9 is definitely divisible by 9. So this entire thing is divisible by 9 also, 4 also. So it is divisible by 36. Understood? 36 3 is a 108. Okay. Clear? Suppose I give 144. Please check for this 144. Whether it is divisible by 36. 144. Good morning, Vaishnavi. Good morning, Vijay Lakshmi. 144. 44 is divisible by 4 because 4 11s are. 4 plus 4 8, 8 plus 1 9. 9 is divisible by 9 itself. So 36 it is divisible by 36. Same way if they ask 72, you can either write it as 36 into 2 or you can write it as 9 8s are 72. Correct na? If they ask 72, you can write it as 9 8s are 72. Or if they ask 144, 144 can be written as 72 into 2 or you can write it as what? 9 into 8 into 2, 8 into 2 or you can write it as 9 into 16. Okay, 9 into 16. Any bigger number they give, you can break it down into smaller numbers and you can bring it into the form of 1 to 10 or 2 to 9. Bring it to the smaller numbers, that is ranging from 2 to 9, then it will be easy for you. Okay, 2 to 9 you bring it, then it will be easy for you. Okay, got it? Clear? So 36 also you know, 72 also you know. Clear? Now based on this, let us solve some questions. So that's all is the divisibility rule. So we learned 2, it should be an even number, and 4 last two digits should be divisible by 4, 8 is last two digits, 3 is sum of the digits, and 9 is also sum of the digits, but it should be divisible by 9. Next what we learned? 7 you do direct division. Okay, 5 ending with 5 or 0, 10 is ending with 0. Okay, and then 12. Okay, 12 is 3 and 4. 6 also it is 2 and 3. One more thing we forgot. What is that? 11. Okay, so 11 is here. 11 is very important. When I talk about 11, see here, I will explain this through an example. Suppose I write like this, I have written numbers. So on the top take alternate numbers like this, okay. Here nothing is there, leave it. Alternate numbers is what? 2 plus 0, 0 plus 4 is what? See, 2 plus 0 is 2, correct na? Don't do wrong along with me. You should, I am checking you people. 2 plus 0 is not 0, 2 plus 0 is 2, okay. 2 plus 4 is 6, I am getting 6. What about this one? 3 plus 6 is 9, 9 plus 8 is 17. So this difference when you take, if it is coming, the difference is coming as, the difference should come as 0 or 11n or you can take it as or multiples of 11. Multiples of 11. That is, the difference should come as 0 or 11 or 22 or 33 or 44. If the difference 44, like this it goes on. Okay. if the difference, when you take alternate numbers, you add it, okay, and take the difference. When you take the difference, if the difference is coming as 0, or if it is coming as 11 or 22 or multiples of 11, any multiples of 11, 11 9 is 19, 11 8 is 88, like that, then that entire number is divisible by 11. Okay, suppose I take the example. Okay, see here, alternate numbers, alternate numbers. So 1 plus 3 is what? 4. 1 plus 3 is what? 4. 4 minus 4 is 0. So I am getting the difference as 0. So definitely this entire thing is divisible by 11. Like this, alternate numbers you have to check. Let me give another example. 28, 28, 28, 28. Please check this. Don't worry about the sign. Don't worry about the negative sign and all. Just check. Okay. So here it is what? 2, 2 and 2. So this is what? 8. Okay, fine. 8, 8, 8. So this is what? 16, 24, 32. So 32 minus 8 is 24. So 24 is not a multiple of 11. So this entire thing is not divisible by 11. Understood? This is how you have to check for 11. Okay, this is how you have to check for 11. Understood? Alternate numbers you add it and take the difference. When you take the difference should be 0 or 11 or any multiple of 11. If it is coming like that, then it is divisible by 11. Otherwise, it is not divisible by 11. Got it? That's it. So let us move to some questions based on this. Some questions that are given, that has come in the examination based on the divisibility rule. Yes, it's divisible. Yeah, Deepa, that's fine. Okay. Have a look at this question. So they are telling, if the number 681M473 is divisible by 9, then the smallest whole number for M is. So they are telling this number, what is the number that is given? 681M473 is divisible by 9. They are only telling it is divisible by 9. They are not asking you to check. Yes, ma'am, please. Okay. So they are not asking you to check whether it is divisible by 9 or not. They are telling it is already divisible by 9. They are asking you to find the value of M. If it is divisible by 9, the sum of the digits should be divisible by 9. Correct now? So what I should do? I should add all of this. So they are telling the given number is divisible by 9. They are asking you to find the smallest whole number for M. They are not asking you just the smallest number for M. Smallest whole number for M. Whole number means it can include 0 also. If they ask smallest integer, then it can be anything. It can be negative value also. If they ask smallest natural number, it should start from 1. Okay. They are telling smallest whole number for M is what? Okay. Now listen to this carefully. So to be divisible by 9, the sum of the digits should be divisible by 9. Correct now? So what I should write? 6 plus 8 plus 1 plus M plus 4 plus 7 plus 3 is divisible by 9. Correct now? So what is the value we get? 6 plus 8, 14, 15, 19, 26 plus 3, 29 we are getting. Correct now? So we are getting 29 plus M by 9. Correct now? 29 plus M by 9. Okay. So what is the value of M I should take? Smallest value of M. Smallest value of M means you should start from C here. Smallest value of M means they are telling it is whole number. That means it can range from 0 to 9. Okay. If I take 0, it will remain 29. 29 is not divisible by 9. If I take 1, it will become 30. 30 is not divisible by 9. If I take 2, it will become 31. If I take 3, 32. Okay. Like that, if you are going till 35, it will not be divisible. 6, if I take 6, that is 36. If I want to get 36, what I should put? 7. If I put 7 here, it will become what? 36. If I put M is equal to 7, this will become what? 29 plus 7 by 9. So that is 36 by 9. So what will happen? Now it is divisible. So 9 ones are 9 fourths. So what is the value of M here? 7. Understood? What is the smallest value of M? Smallest whole number for M, that is 7. Why they are telling smallest whole number? You can take any other number. See, now it is 36. Now what I can do? I can add even more numbers. Correct na? Then M can become any value. They are asking smallest value. Smallest value here is what? 7. So the M is 7. That's it. Clear? The M value is 7. Okay. Clear? Suppose instead of 9, if they had given something like 3, hypothetically I am giving a question. They are telling this entire number is divisible by 3. What is the smallest whole value for m? What is the smallest whole value for m? It should be 1. Why? Because 29 plus 1 is 30. 30 is divisible by 3. Okay, then m value will become what? 1. Understood? If it is divisible by 3. But the question that they have given is 9. This is a question that has been asked in the examination. Clear with this question, everyone? Understood why m is 7? Okay, you have to check from 0 to 9. Why? Because they are telling whole number. If they are telling natural number, you have to check from 1 to 9, that's all. Okay, whole number means it will include natural number plus 0. Integer means it will include even negative numbers. Clear? Fine. Let us go to the next question. Okay, so they are telling if a number, given number is divisible by 72, then the value of 5x minus 3y is equal to what? So they are telling, look at this, they are telling that 7, 8, 9x, 5, 31y, this number is divisible by 72. They are telling what? 72. Then they are asking us to find this value, 5x minus 3y is equal to what? This is the question. Now 72, I told you 72 can be written as what? 8 into 9, correct na? 8 into 9. So first let us check for 8. Okay, they are only telling it is divisible. It is not checking. Okay, so last 2 digits, last 3 digits should be divisible by 8. So we are having 31y. It should be divisible by 8. Correct na? So see here, 8 3s are 24. What is left? 7. So here what value I should put so that it should be divisible? If I put 0, not possible. If I put 1, it will become 71. If I put 2, definitely it will become divisible. So it will become 8 9s are 72. Then only possible value for y is, it should be y is equal to 2. Okay. Now what I will do, I have to check for 9. To check for 9, I have to take the sum of the digits. Here wherever y is there, I have to put the value of 2. Now this number will become 7 8 9x 5 3 1 2. Now you have to check for 9. You have to check for 9 means sum of the digits should be divisible by 9. Correct na? So add this. So this will become what? 7 plus 8 15, 15 plus 9 24, 24 plus 5 29, 32, 33, 35. Correct na? 35. Correct na? Sum is correct? 35 plus what is it? X is divisible by 9. So x value what I should put? 1. Correct na? Because 36 will be divisible by 9. That is possible only when x value is 1. So we will take x value is equal to 1. So what we got? Y is equal to 2, x is equal to 1. They are asking us to find 5x minus 3y. Now it is easy. 5 into 1 minus 3 into 2. So that is 5 minus 6. So the answer is minus 1, which is option B. Clear? Understood? Got it? Like this they will ask the question based on divisibility. So you should be thorough with divisibility rule from 2 to 12. Okay, 2 to 12 if you are thorough. Any number they give, if they give 24, if they give 18, if they give 16, if they give 36, if they give 72, if they give 144, you will be able to derive. But you should be thorough with 1 to 12. Clear? Got it? So let us go to the next concept that is there. Okay. Now what we did is divisibility rule. Next we will go for remainder theorem. Clear? Remainder theorem. Okay, we will go for remainder theorem. Okay. What is the time? 10:08. Okay. So when I talk about remainder theorem, okay. So observe very carefully. If I divide 22 by 7, if I take 22 by 7, what is the remainder that I get? 1. How did you know that? Don't say that you know the 7 tables. So how you will think like that? See here, 21 plus 1 divided by 7, correct na? Like this you will think. So this will become what? 7 3s are. Okay, what is remainder? That is left is 1. So remainder is 1. Okay, you will get remainder as 1. Same way, this what remainder we got? This is called positive remainder. Till now whatever you are finding, those remainders are called as what? Positive remainder. In the remainder theorem, we will learn 2 types of remainder. One which you already know, that is positive remainder. Another one is negative remainder. So here you will be learning about positive remainder and another one is negative remainder. Okay, what is negative remainder? I will tell you. Suppose let us take another example. If I take 80 divided by 7, if I 80 divided by 7 if I take, what is the remainder that I will get? What is the remainder that I will get? 3, correct na? See, those who came late, don't worry about the previous concept, you can watch, you will understand. Though this is a new concept, nothing related to that. Okay, so see here, if I divide 80 by 7, what is the remainder that I will get? 3, correct na? How did you think? That is 77 plus 3 divided by 7, that is 7 1s are 7 11s are, correct na? So remainder will get it as 3. So here the remainder is 3. Okay. So this is what you got is positive remainder. Here also it is positive remainder. Now this 22 can be written as what? I can write this 22. Same thing I'll write 22 by 7. I can write this as 28 minus 6. 28 minus 6 is what? 22 only. I can write or not? 28 minus 6 I can write it. So divide by 7. So what I'll get? 7 1s are 7 4s are. Remainder is what? Minus 6. Not minus 2. See, this is quotient. I am talking about remainder. 4 is quotient. This is remainder. So remainder is what? Minus 6. Okay. Now let us take this 80 and 7. Okay, 80 and 7. Okay. So I am having what? 80 and 7. Correct now? So this one I can write this as what? I can write this as 80 can be written as what? 80 can be written as what? In terms of this one. What I can write it? 84 minus 4. 84 minus 4. Correct na? 84 minus 4. 84 minus 4. Why? 84 is divisible by 7. Okay. So 7 1s are 7, 7 2s are 12 7s are 84. Now what is the remainder? Minus 4. So the remainder that we are getting is minus 4. So understood? So here the remainder is 1 and the remainder is also minus 6. Here the remainder is 3 and the remainder is also minus 4. Okay. So this minus 6 and minus 4, they are all what? Negative remainder. Here this is what? This is positive remainder. Okay. But one thing you have to understand, see here, but while taking the value, if they ask the negative remainder, what is the negative remainder? You should not write minus 6, you should write just 6. Okay. You should not write minus 6. That negative is to indicate that it is a negative remainder. But in the answer, in the question, in the options, they will give only 6. You should not write minus 6. You should write only 6. Here the negative remainder is what? 4. 4. Okay. One thing you observe, this 1 and this 6 and there is 7 here. Can you find any relation? 1 plus 6 is equal to 7. Here see here 3 and 4 and here there is 7. So 3 plus 4 is equal to 7. That means what? Observe here, positive remainder plus negative remainder is equal to divisor. Is equal to divisor. Very important relation. Very important relation. Okay. Positive remainder plus negative remainder is equal to divisor. See here, 1 plus 6, forget about the sign. 1 plus 6 is 7. 7 is what here? Divisor. 3 plus 4 is what? 7. Positive plus negative, if you add, you will get the value, that is divisor. Based on this, you will get a question. Okay. Positive remainder plus negative remainder will get the divisor. Okay. You will get the divisor. Clear? Understood? Now, one more concept is, see here, one more concept is, suppose they give 3 by 5 or 8 by 11 or 9 by 11 or 4 by 5. Okay. Here what is the remainder here? What is the remainder here? See here, the dividend or whatever is in the numerator is definitely less than the denominator. Here also it is less, here also it is less, here also it is less. In that case, if they ask what is the remainder, the value, actual value, this value itself is the remainder. Okay. 3 itself is the remainder. What about here? 8 itself is the remainder. What about here? 9 itself is the remainder. Here what is it? 4 itself is the remainder. These are all what? These are all positive remainders. These are all what? Positive remainders. For this, what is a negative remainder? correct, it is 2. See 5 minus 3, that itself is 2. See 3 plus negative remainder is equal to divisor is what? 5. So negative remainder is equal to what? 5 minus 3, that is 2. So for this negative remainder is what? 2. For this negative remainder is what? 3. For this it is 2. For this it is 1. Okay. Here the concept is not about the negative remainder. You have to understand that if anything that they have given is less than the denominator, the numerator itself is the remainder. Okay, the numerator itself is the remainder. Suppose they give 121 divided by 256. 121 divided by 256. What is the remainder? 121 itself is the remainder. You have to know this. Okay. If they give 27 by 29, what is the remainder? 27 itself is the remainder. Got it? Clear? Okay, fine. Now let us learn one theorem that is there for the remainder theorem. Okay, one very important theorem that is there. Okay, so we are talking about the denominator. Till now I was talking about the denominator. The denominator, there are two possibilities. The denominator can be a prime number or non-prime number. Prime number means what? It is divisible by one end itself. For example, the denominator can be prime number and non-prime number. What do you mean by prime number? It is divisible by 1 and itself. It is divisible by 1 and itself. So when I talk about prime number, the example can be 2. 1 is neither prime nor composite. Don't include 1. Okay. 1 is not a prime number, 1 is not a composite number also. Okay. So you should start from 2. 1 you should not include. Okay. So 2, 3, 5, 7, not 9. 9 is divisible by 3. 9 can be written as 3 into 3. 11, 13, 15, no, 17, 19, 23, what next one? 29, 27 is 3 into 9. Okay, so 31, next one, 37, okay, 41, like this it goes on. These are all prime numbers. So when the denominator is a prime number, we have a theorem that is called Fermat's theorem. Okay, what is that? Fermat's theorem. Fermat's theorem. Okay, Fermat's theorem. Fermat's theorem for what? When denominator is a prime number. When denominator is a prime number. Suppose there is a fraction that is given. Okay, suppose there is a fraction that is given. Okay, a by p. P is what? It's a prime number. A is some number. Okay, for this there is a power that is given in such a way that a to the power of p minus 1. Okay, a by p, where power is given in the form of a to the power of p minus 1. Okay, when I give the example you will understand. So here what I write equals, what I am writing is remainder. Here the remainder will always be equal to 1. Here the remainder will always be equal to 1. Okay, here the remainder will always be equal to 1. For example, see here 32 divided by 7 to the power of 6. 32 divided by 7 to the power of 6. First of all, 7 is what? Prime number. 6 is what? 6 is nothing but 7 minus 1, correct na? 7 minus 1, that is p minus 1. So here the remainder is what? 1. Here the remainder is what? 1. Okay, let us take one more example. See here 104 divided by 7 to the power of 6. To the power of 6. Here the remainder is what? 1. Understood? Here the remainder is 1. Clear? Okay. Here the remainder is 1 because it is can be written as 7 minus 1. Clear? Got it? Now, one more thing you have to understand this. One more thing you have to understand. This is fine, but suppose they have given 35 by 7 to the power of 6. Please be careful, note, see, very important. 35 by 7 to the power of 6. So 7 is a prime number, fine. This is what? This can be written as 7 minus 1. So you will think that the remainder is 1, but this 35 is divisible by 7. This 35 is divisible by 7. So definitely here the remainder will be 0. In such cases, the remainder will be 0. Okay. Suppose I write 36 by 3 to the power of 2. 36 by 3 to the power of 2. Observe here, 3 is prime number, 2 can be written as 3 minus 1. So you will think that Fermat's theorem is applicable and you will write the answer as 1, remainder as 1. But this 36 is divisible by 3. So 3 ones are 3 12s are. In such cases remainder is 0. So please check this also once. Okay. Otherwise you have to apply Fermat's theorem. The answer will be, suppose I had written 35 by 3 to the power of 2. The answer will be 1. 35 by 3 to the power of 2. The answer will be 1. Clear? Got it? Understood? Those who are watching on YouTube, is it clear? 35 by 3 to the power of 2. The answer will be equal to 1. Okay. The answer will be equal to 1. Clear? Okay. Let us take some questions based on this. But before this, I would like to tell you about remainder theorem only, but before this you should know some law of exponents. Okay, law of exponents you already know, but you would have forgotten. So, law of exponents. Here there is one very important law that you must know. Okay, first thing is, if there is a to the power of m into a to the power of n, this can be written as a to the power of m plus n. For example, if I write 2 to the power of 3 into 2 to the power of 2, this can be written as 2 to the power of 3 plus 2, 2 to the power of 5. Correct na? So second one, if there is a to the power of n divided by a to the power of n, or if it is given like a to the power of m by a to the power of n, okay, the answer is a to the power of m minus n. Okay. For example, same example, if I take 2 to the power of 3 divided by 2 to the power of 2, the answer will be 2 to the power of 3 minus 2, that will be 2. 2 to the power of 1, that is 2 itself. Clear? Next, this is very important. Observe very carefully. If there is exponent like this, a to the power of m to the power of n, a to the power of m whole to the power of n, a to the power of m whole to the power of n, bracket, that is why there is a bracket. Okay, a to the power of m whole to the power of m, then the answer is a to the power of m into n, a to the power of m into n, a to the power of m whole to the power of m, the answer is a to the power of m into n. For this, if I write the example, see here, 3 to the power of 2 to the power of 3, the answer is what? 3 to the power of 2 into 3. The answer is what? 3 power 6. 3 power 6. Understand one thing, please be careful. This a to the power of m to the power of n is not equal to a to the power of m to the power of n. This a to the power of m whole to the power of n is not equal to a to the power of m to the power of n. This is not the same. I will tell you with example. A to the power of m to the power of n is not equal to a to the power of m to the power of m. Okay, here if there is whole, bracket is there, this is completely different from this. Suppose I take the same example, 3 to the power of 2 to the power of 3. What I am getting? 3 to the power of 2 into 3, what I will get? 3 to the power of 6. Suppose I write 3 to the power of 2 to the power of 3. 3 to the power of 2 to the power of 3. This means what? 2 cube. Okay, 2 cube is what? 8. So this value is equal to what? 3 power 8. So is it same as this? This is not equal to 3 power 8. Okay, this is most important, you have to understand, not just for this one, what to say? Remainder theorem, even for some questions that are being asked in your examination. They will give question like, they will ask which of the following is the lowest. Okay, we have done in the PYQ. They will give question like this, out of this which of the following is the least value, which of the following is the highest value, they will ask. Okay, they can give like this, or they can give like this, or leave it like this. They will ask which of the following has the least value. Okay, there you should know the difference between this and this. Okay, out of this class, what I can say, the most important thing is, this is the thing what I have written on the board. So this and this are not the same. Most people still don't know. Okay, they will confuse. That's why I am telling, a to the power of m whole to the power of n is not the same of a to the power of m to the power of n. Okay, that's why I am taking more time to explain this. Understood? This is not the same as this. Please make sure. Okay, get the clarity here. Next one. Now let us go to the questions that is there, that is given in the examination, actual questions that are given. So let us solve those questions. So the question that they are given is 38 to the power of 102 divided by 103. Second question is 64 to the power of 30 divided by 31, 187 to the power of 82 divided by 83, next we are having okay. So see here, this one directly you will find it 38 by 103. 103 is a prime number, 102 is 103 minus 1. Here answer is what? Everywhere you have to find the remainder. Okay. In the last someone asked why you have to find the unit digit. Here also why you are finding the remainder, because that is the question. Find the remainder. Okay. So that's why here the remainder is 1 using Fermat's theorem. Here 64 to the power of 30 divided by 31. 30 can be written as 31 minus 1. Okay. This is like what? A to the power of p minus 1 by p. By Fermat's theorem, the answer is what? 1. Here it is 82 can be written as 83 minus 1. 83 is a prime number. 187 cannot be divided by 83. So the answer is what? Remainder is 1. Now see here, 3 power 21 by 5 is there. Okay. So this can be written as what? 3 power 21 can be written as what? So observe here, if I can write a to the power of m plus 1, so this can be written as what? A to the power of m into a to the power of n. So similarly, 3 power 21 can be written as what? 3 power 20 into 3 divided by 5. 3 power 20 into 3 divided by 5, very important. 3 power 20 into 3 divided by 5, that is 20 plus 1 is 21. I have split it, 3 power 20 into 3 divided by 5. Now this 20 has no relation with 5, correct na? Because you should write it in the form of p minus 1. So what I should do? I should get somewhere, p minus 1 means what? I should get 3 to the power of 4, correct na? I should get 4. Then only I can apply Fermat's theorem, correct na? Here it should be p minus 1. I am having p here, that is 5. Here I am having 20. What I can do? This 3 power 20, I can write it as 3 power 5 power 4. 5 4 is 20. Correct na? A power, I can write it as what? A power m into n can be written as a power m to the power of n. Okay. Why I have written 5 inside and 4 outside? Because I want it in the form of p minus 1, so that I can apply Fermat's theorem. Now see here, forget about what is inside. Now see here, this 5 and 4. 4 is nothing but what? 5 minus 1. Okay. Here don't forget about these 3. Okay. Now what we are having? For this entire thing, what is the remainder? 1. Now this 5 is there for this also. Okay. So 3 divided by 5, what is the remainder? 3 divided by 5, what is the remainder? I told you. 3 itself. I told you na. 3 divided by 5, because it is less than the denominator. So remainder is 3 itself. Okay. Remainder is 3 itself. Understood? So the remainder for this is 3 by using Fermat's theorem. Understood? This question is very important. Understood? Now 18 to the power of 37 divided by 5. Now look at this question, observe. 18 to the power of 37 divided by 5. 18 to the power of 37 divided by 5. Now this 18 to the power of 37 can be written as what? 18 to the power of 36 into 18 to the power of 1. But 5 is there, 36 and 5 does not divide each other. So I can write this as 18 to the power of 35 and 18 to the power of 2. 18 to the power of 2 divided by 5. Now this 18 to the power of 35 can be written as what? Can be written as 18 to the power of 7. 7 into what is this? No, let us take 36 only, because we will get directly 5, that is not required. So we will take it as 18 to the power of 36 into 18 divided by 5. Okay. This 36 can be written as what? 9 into 4. This 36 can be written as 9 into 4. So 18 to the power of 36 can be written as 18 to the power of 9 to the power of 4 into 18 divided by what is it? 5. Now if you observe this entire thing, you can apply Fermat's theorem. So you will get it as what? 1 into 18, 5 will be still there. 5 will be still there. Okay, 18 divided by 5. What is the remainder? Here you do directly 5 ones are 5 3s are. What is the remainder? 3. Understood? The remainder is 3. Here normal method, 18 by 5, that is 5 3s are 15. Remainder is what? 3. So the answer is 3. Understood? Clear? Okay. Now 37 to the power of 62 divided by 11. Okay, 37 to the power of 62 divided by 11. Okay, how to do this question? Think about it. Please copy this question, do it by yourself. 37 to the power of 62 divided by 11. Is it clear? First 3 question, is it clear? What about 4th and 5th? 4th and 5th not clear? Okay, please write down. I will explain again if you have doubt. Okay, write down the 4th and 5th question. If you know law of exponents, it will be easy. Just you have to understand the law of exponents. Okay, you have to modify this in such a way that it should come in the form of denominator minus 1. Because this is p, it should come in the form of p minus 1. Here also it should come in the form of p minus 1. So 3 power 21, I wrote it as 3 power 20 into 3. So 20, I should write it as, the power should come in the form of 5 minus 1, that is 4. So I wrote it as 5 into 4, 5 power 4. Okay, so this is what? 4. So this is p minus 1, 3 power 5 to the power of 4. So this is p minus 1 by p. So I applied Fermat's theorem. So for remaining 3 by 5, the remainder is 3. Clear? That's it. Same way I did for this thing. This one you have to do it by yourself. I'll check later. You copy this. Okay. Now let us do for copied this question. Now let us do when the denominator is not a prime number. Till now we saw when the denominator is a prime number. When the denominator is not a prime number, how to solve such questions. So let us see for that. When denominator is not a prime number. Okay, when denominator is not a prime number. Let us take some examples for that. You will understand. Okay. For this, suppose they are given, suppose a is the denominator. Suppose a is the denominator, numerator, some value b is there, you think, some value b is there. Okay, a is what? The denominator. Denominator a is not a prime number, that is, it is non-prime. Suppose it can be like 4, it can be 6, 8, anything like that. So this b should be written in such a way that a plus 1 by a to the power of n, a plus 1 or minus 1, a plus or minus 1 to the power of n by a. Okay, b by a. Okay, it is given in such a way that a is not a prime number. This b should be written in the form of a, that is denominator, in such a way that it should be written in the form of a plus or minus 1, a plus 1 or minus 1 to the power of n divided by a. Okay, the answer will be, general answer will be 1. But understand one thing, if you are having a plus 1 to the power of n by a, the answer is definitely 1. If it is plus 1, if it is plus 1, a plus 1 by a to the power of n. To the power of n is only for the numerator. Okay, the answer will be what? 1. Please observe carefully, I am repeating again. This b should be written in the form of a plus 1 to the power of n. Okay, a plus 1 to the power of n, okay, divided by a. A plus 1 to the power of n divided by a, that is equal to 1. Okay, a plus 1 to the power of n divided by, that is equal to a. Okay, so if it is plus, the answer will be definitely 1. Okay, if it is minus, a minus 1 to the power of n divided by a. Okay, if it is this the case, what will happen is you have to focus on n. If n is even, if n is even, the answer will be plus 1. Same thing, see here, a minus 1 to the power of n by a. If n is odd, the answer will be minus 1. Okay, this is the difference you must know. Okay, a minus 1 to the power of n when n is even, the answer will be 1. A minus 1 to the power of n when n is odd, the answer will be minus 1. Got it? The answer will be minus 1. Clear? This difference you must know. Now let us have a look at some questions so that you understand. Please write this down, this is very important. So these are the questions that we have. Now look at the first question that we have, 38 by 9 to the power of 100. Okay. So first question what we have, that is 38 by 9 to the power of 100. Okay, 38 by 9, 38 to the power of 100 divided by 9. This is the question that we have. Okay, so observe here, divided by 9 is there, here 38 is there. So I told you it should be written in the form of the denominator, that is 9 plus or minus 1. So directly we cannot write it. So what I can do here, 9 ones are 9 fours are 36. So what is the remainder that we have? 2. So this can be written as 2 to the power of 100 divided by 9. 2 to the power of 100 divided by 9. So what is the remainder that we have? 2. 2 to the power of 100 divided by 9. But again this cannot be written in the form of 9. 2 cannot be written in the form of 9. So what I can do, this 100, I can write this as 2 to the power of 3 into 33, okay, into 2. That is 2 to the power of 100 can be split as 2 to the power of 99 into 2 to the power of 1. Okay, you can do this. So 2 to the power of 99 can be written as 2 to the power of 3 whole to the power of 33. So 2 to the power of 3 is what? 8. Correct na? This is nothing but 8. So 8 to the power of 33 into 2 divided by what we have? 9. Okay. So this is nothing but what? This is nothing but a minus 1. 8 is nothing but 9 minus 1. Correct na? This is nothing but 9 minus 1 to the power of 33 into 2 divided by 9. So 9 minus 1, that is a minus 1 by a to the power of n. N is what here? 33. Is it odd or even? Odd. So the answer will be minus 1. But here 2 by 9 is also there. 2 by 9 is also there. So when we have minus 2 by 9, so what is the remainder here? What is the remainder here? Don't worry about minus, I told you. The answer is what? Just 2. The answer is just 2. But in the option, they will not give this negative remainder. They will give positive remainder. So what is a positive remainder for this? What is a positive remainder for this? This is 2 is negative remainder. What is a positive remainder? 9 minus 2, 7. So the answer will be 7. If they give directly 2, that is totally fine. If they give a negative remainder. But if you want positive remainder, it should be 9 minus 2, 7. Understood? Again I will repeat, see here. So 38, we cannot write it in terms of 9 because this is, we are doing it for non-prime numbers. So 38, 9 4 is 36, remainder is 2. So 2 to the power of 100 by 9. So again this 2 I cannot write it directly in terms of 9. So for that this 100 I have to do some modification. So 2 to the power of 100 can be written as what? 2 to the power of 99 into 2 to the power of 1. If you do 2 to 3 questions you will get comfortable, don't worry. Okay. So 2 to the power of 99 can be written as 2 to the power of 3 to the power of 33. Why? Why 2 to the power of 3? Because I will get 8. 8 can be written easily in terms of 9. Okay. So it cannot be, see, 2 I cannot write it as 9 minus 7 because this is a minus 1. This is not a minus 7, the formula. So directly I cannot write it. So this can be written as what? 8 to the power of 33 by 9 to the power of into 22. So 8 to the power of 33 can be written as what? 9 minus 1 to the power of 33. Okay. But here n is what? 33. Odd. Odd means what is that we will get? Minus 1. So we got minus 1 into 2 by 9. 2 by 9, what is the remainder? The remainder will be 2 or 7. Understood? This is how you have to solve this question. So let us go for one more question, that is 74 by 9, where 74 to the power of 100 is there. Okay. Look at this question, you will understand better now. See here. 74 to the power of 100 by 9. Now 9 8s are 72. What is the remainder here? 2. So 2 to the power of 100 by 9. So 2 to the power of 100 can be written as again same thing, 33 into 2 divided by 9. So 2 to the power of 3 can be written as what? 8. So 8 can be written as 9 minus 1. So this will become 9 minus 1 to the power of 33 by 9 into 2. So here the answer will be minus 1. So minus 1 into 2 by 9. So the answer is what? 2. Remainder is 2 or it can be 7. Clear? Or it can be 7. Now let us have a look at this question. So this question, see here, the previous non-prime number, these two questions, copy this, and the prime number one question I have given, copy this, you have to solve it by yourself. Okay. I'll help you if you have doubt, but you copy this question. 83 to the power of 109 by 9, 87 to the power of 120 by 17. These two questions please copy, and previously what question I have given, copy that also. Okay, you have to solve it. Not audible? Anyone check in the YouTube once? I'll only check, no problem. Yes, it's audible. Okay, so this is when it comes to remainder theorem. Okay, when it is prime number, when it is non-prime number. Now let us start with HCF and LCM. Okay, I know I will not be able to complete it now. We will be continuing in the next class also, but let us start. Okay, first let me tell you what is LCM and HCF. So in this class, let us know at least what is LCM. It is lowest common multiple. Lowest common multiple. Suppose for example, 12 is given. For 12, what are the multiples that we have? 12 itself is a multiple, correct na? So multiple will be 12, 24. Multiple means you are writing the table, 12 table, that's it. Okay, 12, 24, 36, 48, 60, 72, it goes on. Okay, that is the meaning of multiple, lowest common multiple. If they ask you to find the LCM of, suppose I say another number, let us take 18. What are the multiples of 18? That is, what is the 18 table? Most of you don't know, so no problem, I will only write it. So 18, 36, what is it? 54, next 72, it goes on like this. Now see here, 12 and 18, lowest common multiple. Okay, lowest common multiple. Common multiple is what here? So 36 is common multiple, 36 is common multiple. Another next is what? 72 is 72. Okay, here also 72. But they are telling least or lowest common multiple. Lowest common multiple is what? 36. So the answer is what? So the LCM of 12 and 18 is 36. So this is the meaning of lowest common multiple. But should we solve it like this? No, definitely no. You don't have this much time to write all these tables and do it. I just wrote it for you to understand what is the LCM. What is the meaning of LCM? Okay, now how to solve this? Suppose they give 12 and 18. Okay, 12 and 18 they give. They ask you to find the LCM for two numbers. LCM of two numbers, that is 12 and 18. Let us use the ratio method. Let us use the ratio method. So 12 is to 18, I will write it. Okay, but I can divide by what? I can divide by 6. Okay, to the simplest form of ratio, I can write it as what? 6 to 6 3 is. So 2 is to 3. Now, what is the LCM if they ask? Either do this, cross multiply 12 into 3 or do this 18 into 2. So, what you will get? 18 into 2 is 36, 12 into 3 is what? 36. So, the LCM is what? 36. Suppose they ask the LCM of 16 and 24. 16 and 24. So, what you will do? You will find the ratio. 16 is to 24, you will write it. Okay. So, this is what? In simplest form, 8 2s are 16. You should write it in simplest form. Okay, 8 2s are 16, 8 3s are 24. Now, to find the LCM, what you will do? Cross multiplication. 16 3s are 48 or 24 2s are 48. So, the LCM is what? 48. So, this is the way you will find the LCM using ratio method. Suppose I want you to find the LCM of 20 and 25. So, what is the simplest form? That is ratio method you will use. 20 is to 25. What you will write? 5 4s are 5 5s are. So, 20 into 5 is what? 100 or 25 into 4 is what? 100. So, the LCM is what? 100. Got it? Fine. Next, suppose I give 36 and 48. 36 and 48. What is the LCM? 36 and 48. Everyone has to solve, not just sit and watch here. So 36 and 48, see 36 is to 48, what I can write it? It is, see 12 3 is a, 12 4 is a simplest form. So 36 into 4 is what? Or 48 into 3 is what? So 36 into 4 is what? Just to multiply, 4 6 is 24, 4 3 is 12, 144. So the LCM is 144. Okay, this is much easier than doing this method. 36, 48, which the method you follow. Doing this method is time taking. This is easy method. Okay, suppose I ask you to find the LCM of 72 and 80. 72 and 80. Don't just sit and watch, you have to solve. $144, Harati, that's good. Okay. So 72 is to 80, correct na? So I can write it as what? So 8 9s are 8 10s are, correct na? So I can write it as 72 into 10, that is 720 is the LCM, that's it. 720 is the LCM, got it? Clear? So this is the way you have to find the LCM. So I will continue in the next class. There I will tell you how to find the LCM of 3 numbers or more numbers. Then I will tell you how to find the HCF, and then we will see the relation between LCM and HCF. Based on that the questions will come. Alright, I will wind up now. Thank you. Those questions which I have given for you to solve, do solve it. If you have doubt, you get back to me. Thank you. Let us meet in tomorrow's session where we will do little bit of LCM and HCF and we will start with a new topic. Thank you.